Good evening, dear students. Yes. So, as I said, so yesterday we have completed the all the topics. Okay. Yes. So we have completed all the topics. So today we are going to start with model question paper solving. Okay. So I have taken one of the model question paper. Okay. So So let's start with this model question paper. So this is so as you know, for your board exams, okay, so the total marks is 100 marks. So out of 100 marks, 30 marks will be for practicals, right? So already you might have completed your practical exams. Okay, so there your 30 marks you have to score in the practical exam. So rest left is the 70 marks. Okay, so 70 marks, you have to write this paper for 3 hours, 15 minutes. Okay, so 3 hours, okay, it will be given and 15 minutes will be the voting bell. Okay, so 3 hours, 15 minutes will be the allotted time for solving the chemistry paper or all the PC, MB. Okay, so but for maths, okay, you will be having 100 marks total. So you are going to get 3 hours, 15 minutes. So PC okay, a 70 marks paper you'll be having 70 marks, 30 marks will be for your practical. Fine. So now, so as we have discussed already the blueprint, yes, we have already discussed the blueprint in the first session. Okay. So you know that multiple choice questions, okay, will be asked for 15 marks. Okay. So 15 questions will be there for multiple choice question. So we'll start with the part A. Okay. So part A consists of 15 questions. So we'll start with the MCQs. Okay. Multiple choice questions. So yes. So the first question is colligative properties depend on. Okay. Colligative properties depend on A, the nature of the solute particles dissolved in solution. B, the number of solute particles in solution. C, the physical properties of the solute particles dissolved in solution. And D, the nature of solvent particles. Okay. So as you all know, so for answering, okay, so as you know, for answering, okay, you can use the chat box. So there you can drop your answers. Okay, so chat box is available. So in the chat box, you can drop your answer. Okay, so what will be the answer for this particular question? Colligative. Colligative properties depend on. Yes, students. Yes. So I've got some answers. Okay, Vedpati has answered it as B. Dhanush has answered it as A. Okay. Sita has answered it as B. Vedpati has answered it as B. Okay. Uh, Dhanush, which numericals you are asking me? Which numericals? Okay, Shushti has also answered it as C. Okay, what about others? Chemical kinetics. I have solved it. Okay. So if you have not attended the previous session, I have solved the numericals. Okay. Priyanka has answered it as A. Okay. So the correct answer is B. Okay. The correct answer is what? The correct answer is B. Fine. So what is the correct answer? B. Which is the answer? The number of solute particles. It depends on colligative properties. It depends on the number of solute particles. Okay. So when you Okay, so as you know that colligative property, okay, when we are discussing about colligative property, okay, so this comes from the chapter solution. Okay, so colligative properties, what are those? So these are the characteristic of a solution, right? So how it is determined? It is determined by the ratio. Okay, it is determined by the ratio of number of solute particles to the number of solvent particles in the solution. Okay, rather than we are not concentrating on the number of species, but we are calculating the number of solute particles to the number of solvent particles. So what is the correct answer? The correct answer is B. Okay, so correct answer is B. Okay, so moving forward, next question. If the salt bridge is removed from the two half cells, okay, if the salt bridge is removed from the two half cells, the voltage A drops to 0, B does change, C increases gradually, and D increases rapidly. Yes? Yes, what is the answer, students? If the salt bridge, so this comes from electrochemistry. Okay, so this is a question from, we have seen galvanic cells, electrolytic cells, right? We have seen what is half cell. So these are things you have already discussed in your colleges as well as in our class also. Okay. So if the salt bridge, now what is this salt bridge? So salt bridge, if it is what it helps in the movement of ions. Okay. So if this salt bridge is removed from the two half cells, then what will happen to the voltage? What will happen to the voltage, students? So what is the main function of the salt bridge? It will maintain the electrical neutrality. What it will do? It will maintain the electrical. It will maintain the electrical neutrality, right? So what is the help of this salt bridge? It helps in the electrical neutrality. Okay. So it maintains the electrical neutrality. Fine. So in the solutions, and what will happen? It will prevent the voltage drop. What it will do? It will prevent the voltage drop. Okay. So what happens when you remove this salt bridge? Now, once what the question is asked, if this salt bridge is removed, then what will happen? Okay, so if the salt bridge is removed from the cell, then the voltage will drop to 0. Yes, it is correct. Yes, Dhanush, Priyanka, Vedvati have answered yes. The answer is A. What is the answer? The answer is A. Understood? So what is the role of this salt bridge? As you know, okay, it will maintain the electrical neutrality, okay, in the solution. So once so it will so that it will prevent the voltage drop. So once it is removed, what will happen? The voltage will drop to 0. Okay, moving forward, next question. The SI unit of molar conductivity is, what is the molar SI unit of molar conductivity, students? What is the SI unit of molar conductivity? S means Siemens. Okay, you know what do you mean by S? So S means Siemens. Okay, so the SI unit of molar conductivity is. Okay, I've got the answers. Vedvati have answered it as D. Dhanush has answered it as D. Divya has answered it as D. Okay, so how do we represent the molar conductivity? Molar conductivity is represented, or you can say it is designed as C. Okay, small c. So molar conductivity is what? It depends on what? So it tells you about the molar concentration. Okay, it tells you about the molar concentration of the electrolyte. So the SI unit of molar conductivity is what? It is Siemens per meter per mole. Okay. Yes. So the answer is what? It is B option. Yes. Kalki. So I'll just read out the names who have answered. Kalki, Divya, Dhanush. Yes, Vedvati, your answers are right. Good. Okay. So we have solved 3 questions. Moving for the next question. Fourth question. Okay. A chemical reaction has a uh, rate expression. Okay. As rate is equals to small k. Okay. Concentration of A raised to half. Okay. It is raised to half. Okay. It is raised to half. And concentration of B raised to 3 by 2. Order of the reaction is, what is the order of reaction, students? Okay. Vedvati, Purva, Dhanush have answered it as C. Kalki has answered it as B. Yes, the chemical reaction, okay, has a rate expression. So this rate expression, yes, how do you calculate it? Okay, add the concentrations, that is 1 by 1 by 2 plus 3 by 2. Okay, you get 2. What it is? It is 2. So option number C. Yes. So whoever have answered it as C, Dhanush, Apurva, Vedvati, yes, your answers are right. Good. Okay, moving forward. Next question. The paramagnetic or colored ion among the following is. Now, what do you mean by paramagnetic, students? Paramagnetic means there will be absence of, there will be what? There will be unpaired electrons. Okay. There will be presence of unpaired electron. Unpaired electron means what? The electrons pairing does not take place. Suppose I give you an example like this. Okay. So these are the electrons wherein they are not paired. Okay. So these are called as what? Unpaired electron. So whenever you have unpaired electron, they give rise to what? They give rise to which type of behavior? Paramagnetic behavior. Okay. So this is a question from which topic? Coordination chemistry. Okay. So we have discussed these things also. Whenever, so when you have paired electrons, what will be the paramagnetic behavior when you have unpaired electrons? Okay. So the paramagnetic or whenever you have unpaired electrons, okay. So these will be colored. So which is the colored ion among the following? A, titanium. Okay. Then copper plus. Okay, then plus 1, then C, Zn plus 2, and D, scandium plus 3. Okay, Kalki has answered it as D. Then, yes. Okay, so Divya has answered it as D, Dhanush has answered it as B, Kalki has answered it as D. Okay, so the question is the paramagnetic or the colored ion among the following is. Okay, so which is the answer? So the answer is A, titanium plus 3. Okay, the answer is titanium plus 3. What is the uh, atomic number of titanium, students? Yes. So titanium is 22. Okay. So when we write argon is 18. Okay. Then comes your 3D 2. So argon 3d2 and 4s2. So 18, 19, 20, 21, 22. So when titanium, when it undergoes +3 configuration, okay, when it shows +3 configuration, so how many electrons are lost? So it will be 3d1 and 4s0. What it will be? 3d1 and 4s0. What it will be? 3d1 and 4s0. Okay. So this is the so the answer is, so whenever, as you know, unpaired electrons, okay, so the rest all these ions, okay, these metal ions, okay, they will be having paired electrons. So if you write the electronic configuration for copper +2, Zn +2, then scandium +3, okay, here the electrons are paired. Okay, so titanium, when we are seeing about titanium +3, you can see there is a unpaired electron. So whenever you have unpaired electron, okay, so they will show you a colored, they show a colored this, okay, complex. So option number A. What is the answer? Option number A. Okay. Moving forward, next question. Which among the following is the bidentate ligand? Okay, so this is also a question from coordination compounds. So now we know what are ligands. So we have discussed about the ligands, types of ligands. Okay, unidentate ligand, bidentate ligand, polydentate ligand. Now, what do you mean by bidentate ligand, students? So bidentate ligands are those, okay, which has two donor atoms. Okay, so two donor atoms is present in a single ligand. So it is called as bidentate ligand. So options are A, Cn minus, B, ammonia. Okay, that is Cn minus cyano group. Then B is ammonia, C is carbonyl CO, and D is ethylene. Okay, it is a small e. This is small e. I'll just make it correction. So it is a small e. So this is a small e. Okay, ethylene. So which is a bidentate ligand among the following, students? Okay. So Priyanka has answered it as D. Apurva has answered it as C. Vedvati, yes, answered it as D. Yes, so the answer is ethylene. Okay, ethylene diamine. Okay, ethylene diamine is a bidentate ligand. So when I write the structure of ethylene diamine, okay, so it will be CH2, CH2, okay, and NH2. So ammonia and your NH2. Okay, so this is a what here the nitrogens, okay, here they will link, okay, to the metal atom. So to the central metal atom, the nitrogen from this ligand, okay, so both the nitrogen will link. So these are the bidentate ligand. So ethylene diamine. Okay, moving forward, next question. Okay, so the organic compound formed when chlorobenzene is treated with sodium in dry ether is A, diphenyl, B, toluene, C, phenol, and D, benzene diazonium chloride. So chlorobenzene. Okay, so this is a chlorobenzene. When this chlorobenzene is treated with what? Chlorobenzene is treated with sodium in the presence of dry ether. Okay. So which reaction is it, students? Yes, which reaction? Which reaction is this? Can you tell me which reaction is this? Can you tell me which reaction is this, students? Okay, I have some responses here. Okay, Dhanush has answered it as C. Vedvati has answered it as, okay, Finkelstein reaction. Then Apurva has answered it as Woods reaction. Divya has answered it as A. Okay. Then Priyanka has also answered it as Wood reaction. Okay. Are you sure? Is it a Woods reaction? Yes. Is it a Woods reaction? Yes, the answer is A. Okay. So who have answered it? No. So Divya has answered it as A. Only Divya has answered it as A. Okay. So don't get confused. Okay. Finkelstein reaction is a halide exchange reaction. Okay. Finkelstein reaction is a halide exchange reaction. So this is a question from haloalkanes and haloarenes. Okay. These questions come from haloalkanes and haloarenes. Okay. So Finkelstein reaction is a it is a halide exchange reaction. Okay. Now here, the answer for this question, you can see we have taken, this is a aryl chloride. Okay. So this is your aryl chloride. R is your aryl group. Okay. So, and X we have taken as Cl. So it is a aryl chloride. So 2 moles of aryl chloride, when it reacts with sodium in the presence of dry ether, okay, what will you get? You will get a diphenyl. Okay, and what is this reaction? This reaction is a fatigue reaction. Okay, fatigue reaction. So this is a fatigue reaction plus 2NaCl. Okay, so 2NaCl. Got it. Now, as you all were saying, Wood's reaction. Okay, so Wood's reaction, in Wood's reaction, what is the change? In Wood's reaction, we are taking alkyl halide. Rest all remains the same. Okay, restol remains the same. So 2 alkyl halide, okay, plus again sodium in the presence of dry ether gives you what? R plus 2NaX. Okay, now here, what will be the alkyl group? I can take CH3. So CH3Cl, okay, 2CH3Cl plus 2Na, okay, in the presence of dry ether, what you will get? What will be the answer now here? You will get CH3 plus 2NaCl. Understood? Yes, students, is it clear? Is it clear? So did you understand the difference between Wood's reaction and fatigue reaction? The reaction is same. Okay. In Wood's reaction, we are taking alkyl halide. Okay, we are taking what? Alkyl halide. And in fatigue reaction, we are taking aryl halide. So when so the organic compound, when chlorobenzene. Okay, so chlorobenzene is a aryl halide. So when it is treated with sodium in the presence of dry ether, okay, we get diphenyl. So this is a compound called as diphenyl, or we called it as biphenyl. Okay, so diphenyl, biphenyl. So because 2 benzene rings are fused there. Okay, you can see that the benzene rings are fused, right? So so the answer is A. Understood? Is it clear? So you can give the responses in the chat box. Okay, if you have understood the things. If you want me to explain again, I'll explain it again. Okay, so just get the clear picture about Wood's reaction, fatigue reaction. Okay, don't get confused between the reactions. Okay, so at least, so if you know the general reaction in your mind, okay, then you can put any examples. You can take any examples. Okay, so don't get confused. So all the name reaction, you will feel it is same. Okay, so you need to practice them. So if you practice, then only you will understand it. Okay, simply just reading from above will not go into your head. Okay, so practice this name reaction, very important. Okay, so I'll move further. I hope everything is clear. Okay, so moving further. So the next question, the most suitable reagent for the conversion of primary alcohol. Okay, this is a primary alcohol, RCH2OH to RCHO. What is RCHO? It is a aldehyde. Okay, so from a primary alcohol to convert it into a aldehyde, okay, which is the most suitable reagent? Okay, Vedvati has answered it as C. What about others? Yes, students? Others also please respond. So there are 10, I can see in the Zoom, okay, 10 students are there and I'm getting only 3 to 4 responses. So I want others also to respond. Okay. I'll not judge anyone. Okay, will not judge anyone. So you are trying here. Okay, you are in the state of studying. So it will help others also. Okay. So try to answer. Others also please try to answer. So it will boost others' confidence also, okay, who are sitting idle there. Okay, so you can see how much you have studied or how much you have to study still. Okay, so this will Definitely help you. Okay, Vedvati has answered it as C. Dhanush has answered it as D. Vinushri has answered it as A. Okay. Others? So which is the most suitable reagent? Divya has answered it as C. Okay. Conversion of primary alcohol into aldehyde. The most suitable reagent for the conversion of primary alcohol to aldehyde. Okay, Priyanka has also answered it as C. So, shall I tell the answer? Okay, so the answer is D. Okay, the answer is D. What is D? It is pyridinium chlorochromate. Okay, the answer is D. It is pyridinium, pyridinium chlorochromate. What it is? Pyridinium chlorochromate. Okay, pyridinium chlorochromate. So when we are making use of KMnO4, so KMnO4 is a good oxidizing agent. Okay, it is a strong oxidizing agent. Then your potassium dichromate is also a strong oxidizing agent. Then your chromate. Okay, this is a chromic acid. So chromic acid is also a mild oxidizing agent. So PCC, when we are talking about PCC, so chromic acid, okay, it is also a stronger oxidizing agent. But what it will do, it will oxidize the aldehyde. So it will oxidize the aldehyde to carboxylic acid. So further conversion is also possible. So we are not making use of chromic acid. Okay, so we are making use of what? PCC. Okay, PCC, we are making use of PCC. So primary carbon, you have seen that primary carbon, okay, it has only one carbon atom here. Okay, so only what has happened, it will be converted into aldehyde. Fine. So we'll go for the next one. So whoever has answered it as D, D is the correct answer. Okay. Next question. The role of concentrated H2SO4 in the esterification reaction is. Okay. Do you know esterification reaction? Esterification reaction means what? Preparation of ester. Okay. We are taking a alcohol and what? And a acid, that is carboxylic acid. Okay, we are taking a alcohol and a carboxylic acid, and what is formed? We form a ester. Okay, ester plus water molecule. So esterification reaction, as you know, in esterification reaction, we are making use of this concentrated H2SO4. So what is the role of this H2SO4? What is the role of this H2SO4? Is it used as a catalyst? B, as a dehydrating agent? C, hydrolyzing agent, and D, dehydrating agent and catalyst. The role of concentrated H2SO4 in the esterification reaction. Okay. So, okay, Vedvati has answered it as C. No, B. Purva has answered it as B. Priyanka has answered it as B. Divya has answered it as hydrolyzing agent. Dhanush has answered it as D. Vedvati has, okay, dehydrating agent. Okay. So what is the answer? Yes. So as you know, okay, so the answer is D. The answer is D. It is used as a dehydrating agent, also as a catalyst. So concentrated H2SO4, when we are making use in the esterification reaction, it will speed up the reaction also. Okay, because what is the role of the catalyst? It will speed up the reaction. Okay, and esterification reaction is a fast reaction. Okay, it is a speedy reaction, you can see. So also this H2SO4, okay, it is used as a dehydrating agent. What do you mean by dehydrating agent? Removal of water molecule. Okay, it is a dehydrating agent. It acts as what? It has a property of removal of water molecule. It has a property to remove the water molecule. So therefore, it acts as what? It acts as a dehydrating agent. Okay, it acts as what? It acts as a dehydrating agent. Understood? Is it clear? Okay, so the role of concentrated H2SO4 in esterification reaction, it helps as a catalyst as well as a dehydrating agent. Okay. 10th question. Nitriles are converted into ketones by treating with A. Dialkyl cadmium, B. Grignard reagent, C. Acyl chloride, and D. Chromyl chloride. Nitriles are converted into ketones by treating with. Okay, Dhanusha has answered it as A. Vedpati has answered it as C. Okay, others? What is the answer? Nitriles are converted into ketones with which of the reagent? A. Dialkyl cadmium, B. Grignard reagent, C. Acyl chloride, and D. Chromyl fluoride. So what are nitriles? Okay, I'll give you the structures of nitrile. Okay, so nitrile is this. Okay, so nitriles is converted into a ketone. So this is a ketone. Okay, so how you can okay, Priyanka has answered it as C. So we can use which reagent? We can use Grignard reagent. Okay, so the option answer is B. Okay, anybody has told it as B? No. Okay, so the answer is B. So we, by reacting it with Grignard reagent. Okay, by reacting it with Grignard reagent, we can convert the nitriles, okay, into ketones. So how will it be? So if I give you an example, so R, C, triple bond N. So if you react it with RMGX, so what is RMGX? RMGX, your Grignard reagent. Okay, RMGX is your Grignard reagent. So when it is reacting with Grignard reagent takes place in the presence of ether. Okay, so what it will form? It will form R, okay, then C, RC, then double bond N, Mg, Br, and here will be your this R. So I'll take this as R dash. Okay, so that it will be easy to understand. Then this will undergo hydrolysis. This will undergo hydrolysis, and what it will form? R, C. This will be converted into double bond, and this will be converted into this. Understood? Is it clear, students? So this is converted into O because it is undergoing hydrolysis. Is it clear how we are converting the nitriles into ketones? Yes, is it clear? So till here, okay, 10 questions we have seen. Any doubts still here? Any doubts still here? Okay, Vedvati has no doubts. What about others? Others have doubts. Yes? Okay, okay, fine. So these were the questions. Okay, so we'll move further. So we have a few more questions, 5 questions left. Okay, so this way. Okay, so like this, the questions are asked, right? So a bit twist questions, right? So you have seen how the questions are twisted. Okay, you feel that MCQs will be easy, but MCQs will be a bit, it is easy, but it will be asked in a twisted manner. Okay, so the questions are asked in a twisted manner. Okay. Moving forward, next question. Carboxylic acids are reduced to primary alcohol by A. Sodium borate, B. Lithium aluminum hydrate, C. Chromic acid, and D. Potassium permanganate. Carboxylic acids are reduced to primary alcohol by. So carboxylic acid is C this, and they are converted into primary alcohol. So this is a primary alcohol. So by using which reagent? Okay. By using which reagent? Okay, I've got two answers. Vedvati has answered it as B. Dhanush has also answered it as B. Okay, others? Yes. Okay, one more answer. Shushti. Okay. Okay, Shushti has answered it as A. A, right? Okay. Okay. Divya has also answered it as A. Okay, fine. So the answer is B. Okay, Dhanush and Vedvati, your answer is right. It is A. Okay, that is lithium aluminum hydride. So lithium aluminum hydride is a good reducing agent. Yes, definitely it is a good reducing agent. You can see that your oxygen is removed, okay, in the product, and there is a addition of one hydrogen. So it is a reduction. You know what is reduction? Addition of hydrogen, removal of oxygen. So it is undergoing a reducing what reaction. Okay, it is undergoing a uh, reduction. So reduction is carried out by reducing agent. So lithium aluminum hydride is a good reducing agent. Now, when you're talking about sodium borate is not that strong reducing agent. Okay, it is not that enough so that it can convert the carboxylic acid. Okay, carboxylic acid cannot be converted into primary alcohol. So it is not that strong. But lithium aluminum hydride is a very strong. Okay. So lithium aluminum hydride is used as a good or a strong reducing agent. Okay. So next question. And this chromic acid and KMNO4, what are these? These are a oxidizing agent. So these are also cancelled out. So these two are also cancelled out. So these are oxidizing agent. This is a reducing agent, but not that strong. Okay, it is a milder. You can say it is a mild reducing agent. So we cannot use that. We can use lithium aluminum hydride. Okay. So moving forward, next question. Gabriel thalamide synthesis is used for the preparation of A. Primary aromatic amines, B. Secondary amines, C. Primary aliphatic amines, and D. Tertiary amines. Okay, Vedvati has answered it as C. What about others? Dhanush has also answered it as C. Priyanka has answered it as C. Okay. So Gabriel thalamide synthesis is used for the preparation of. Yes, it is used for preparation of primary aromatic amines. So this is a question from amines chapter. Okay, we have seen Gabriel thalamide synthesis. Okay. So yes, so direct question, easy question. Okay. Next question. Which of the following cannot be prepared by Sandmeyer's reaction? So which of the following cannot be prepared by Sandmeyer's reaction? A. Chlorobenzene. Okay. Then B. Bromobenzene. Then C. Cyanobenzene. And D. Fluorobenzene. Okay. Priyanka, from where I have to start? 40. Okay. Priyanka has answered it as D. Dhanush has answered it as D. Vedvati has answered it as D. Okay. Fluorobenzene. So which of the following cannot be prepared by Sandmeyer's reaction? Fluorobenzene. What is Sand? Okay, Divya Apurva has also answered it as D. What is Sandmeyer's reaction, student? Which of the following cannot be prepared by Sandmeyer's reaction? A. Fluorobenzene, bromobenzene, cyanobenzene, fluorobenzene. Okay, Shushti has answered it as A. Yes. So the correct answer is what? It is fluorobenzene. Yes. Most of you have answered it as D. Yes, it is fluorobenzene. Okay, Sandmeyer's reaction, why it is used? It is particularly used for the preparation of chlorobenzene and bromobenzene. Okay, we are making use of CuCl or CuBr. We are not making use in preparation of fluorine compound, fluoride compound. So fluorobenzene cannot be prepared, but chlorobenzene, bromobenzene, and cyanobenzene can be prepared. Okay, from Sandmeyer's reaction. Okay, next question. Starch is a polymer of. Starch is a polymer of. Starch is a polymer of. Okay. Dhanush, Kalki, Vedvati have answered it as A. Others? A, what is the option A? Alpha D glucose. Okay. Yes. So the answer is A. Correct. A is the correct answer. So alpha D glucose. Okay. So starch is a polymer of glucose. Okay. So you know that starch is what? Starch is a reserve food of plants. Okay. And it has two parts. So it has two components. Starch has two components. One is the amylose. Okay. And another is a amylopectin. Okay. Amylopectin. So what is amylose? Amylose is what? Amylose is a branched, okay, it is a branched polymer of glucose. It is a branched polymer of glucose. Okay. Now what is amylopeptine? Amylopeptine is an unbranched polymer. It is a unbranched polymer of glucose. It is an unbranched polymer of glucose. Is it clear? So these are the two components of starch. And starch is what? It is a reserve component or a reserve food of plants. Okay, fine. Moving forward, last question, MCQ question. Nucleotides. I'll just move it above. Okay. Nucleotides are joined together by. So this is a question from biomolecules. So nucleotides are joined together by A, phosphodiester linkage, B, peptide bond, C, glycosidic bonds, and D, disulfide bonds. Okay, Vedvati, Kalki have answered it as A. Dhanush, no. Okay. So the answer is what? It is joined by, yes, it is joined by phosphodiester. So answer is correct. Okay, nucleotides are joined by phosphodiester bond. Okay, not by peptide bond. Peptide bonds are for amino acids. Okay, amino acids. For amino acids, not for nucleotides. What are nucleotides? What are nucleotides? Yes, students, nucleotides are different. Okay, in nucleotides, we have the phosphodiester linkage. Peptide bonds will come into picture when you have, what is that? Okay, different amino acids. Okay, different amino acids. So when they are linked, so they link through a peptide linkage. Okay, so nucleotide means what? It is a building block, okay, of nucleic acid. So it is a basic building block of nucleic acid, that is RNA and or DNA. So RNA and DNA, it is made up of what? It is made up of nucleotides. Okay, what does this nucleotide consist of? It consists of a sugar molecule, either a ribose sugar or it is a deoxyribose sugar. Ribose sugar in case of RNA, deoxyribose sugar in case of your this RNA. Okay, sorry, deoxyribose sugar in the place of DNA, and ribose sugar in the place of RNA. Okay. uh, this sugar components, they are attached to what? It is attached to a phosphate group, okay, and a nitrogen containing base is present. So this is the composition of nucleotides. Okay, so this completes our MCQ questions. So as you know, so this MCQ questions, okay, so there are 15 MCQ questions, so no choice in MCQ question. So directly 15 questions will be there. Each correct answer 1 mark. If there is any no doubles writing answers, okay, only one time the answer should be written. So think properly and then give the answer. So no writing, then scribbling, again writing, no. So only one time the answers will be considered. So like this. So 15 questions, 15 marks. Each correct answer you will get 1 mark. Okay, if there is a wrong answer, there won't be any mark. Okay, so 1 mark will be deducted like that. So these are the 15 questions. So quickly we'll solve this fill in the blanks also. So next is fill in the blanks part. So 5 marks. Okay, 5 questions, 5 marks. So fill in the blanks by choosing the appropriate word from those given in the bracket. So in the bracket, some 1, 2, 3, 4, 5 already the answers are given. Okay, what you have to do, whichever the answer, correct answer is there for that fill in the blank, you have to give. So I'll quickly read out. Okay, you give the answers. 16th one, dash is a mixture of two or more liquids whose proportions cannot be altered or changed by simple distillation. Okay. Um, Okay, yes. Dhanush and Kalki have answered it right. Yes, it is a azeotropes. Yes, the answer is correct. Azeotrope. Okay, going for the next one. Dash, in an elementary reaction, the number of reacting species collide simultaneously to bring about a reaction is called dash of a reaction. In a elementary reaction, the number of reacting species collide simultaneously to bring about a reaction is called dash of a reaction. Okay, yes, Dhanush and Vedvati have answered it right. It is molecularity. Yes, the answer is molecularity. Okay, what is the answer? It is molecularity. The answer is molecularity. Yes. So next question. The composition of chromite ore is. What is the composition of chromite ore? What is the composition of chromite ore? Yes, Dhanush and Priyanka. Yes, the answer is right. FeCr2O4. Okay, FeCr2O4. So here the answers are already given. Okay. So I'll write it down, which is the answer for which one. So azeotrope 16th one, 17th one, and this is the 18th one. Okay. The phosgene is commonly known as. Phosgene is commonly known as. Phosgene is, yes, Dhanush and Priyanka have answered it right. It is carbonyl chloride. Okay, it is carbonyl chloride. Carbyl amine reaction is given by. Carbyl amine reaction is given by. Yes, it is given by. Yes. Priyanka, Vedvati have answered it right. It is primary amines. Okay, it is given by primary amines. So like this. So if you give proper 15 MCQs, okay, if you correctly write 15 proper like correct answers for the MCQs and these 5, you will get 20 marks. Okay, so 20 out of 20 you can score here. Okay, is it clear? Is it clear till here? Yes. Okay, fine. Moving further, so this was a part A. So far, part A consists of 20 marks, 15 marks for MCQs and 5 marks for fill in the blanks. Now, next comes your part B. Next comes your part B. So part B, so part B, okay, answer any 3 of the following. Each question carries 2 marks. So these are the 2 marks questions. So you will be given 6 options. You are given 6 questions. So out of these 6 questions, you have to write any 3. So the choices are 3. 3 extra choices are given. Okay, so 3 extra choices are given. So what is the first question is, what is the minimum 2 marks each, right? So this is 3 twos are 3 twos are 6. Okay, 3 twos are 6 marks. So this is a 6. So 3 questions, each question for 2 marks. Okay, you will get 6 marks here. So what is minimum boiling azeotrope given example? Okay, so I'll read out the answer. What should be written? What should be answer? Okay, solutions which shows large positive deviation from Raoult's law at a specific composition. Okay. Solutions which shows large positive deviation from Raoult's law at a specific composition. Okay, so this is the answer for what is minimum boiling azeotrope. Now, what will be an example for minimum boiling azeotrope? 95.5% ethanol plus 4.5% water by volume. By volume. Is it clear? Yes. What is minimum boiling azeotrope? Once more, I'll read out. Solutions which shows large positive deviation from Raoult's law at specific composition. At specific composition. Okay. So this is a example. Okay. Is it clear? So now second one you have to answer. Okay. What is zero order reaction? Give an example. So here how the marks is divided. For the definition 1 mark, for the example 1 mark. So if you do not write the example, you will get, and you have, if you have written correct definition, you will get 1 mark. If you have written the example and you don't know definition, so for the example you will get 1 mark, like that. And if you have written both the things, you will get 2 marks, 1 mark each. Okay, what is zero order reaction? Okay, Kalki has answered it as a zero order reaction is a chemical reaction in which the rate is independent of the concentration of the reactant. Yes, good. Yes, Kalki, your answer is correct. Okay, what is the example? Anybody else? Others can try. What is an example for a zero order reaction, students? Yes, what is the example? Okay, so I'll tell the example. Okay, so zero order reaction. One more time I'll give the definition. The rate of the reaction is independent of concentration of the reactant. Okay, so the example for zero order reaction is decomposition of ammonia on a hot platinum surface at high pressure. Okay, decomposition of ammonia on a hot platinum surface at high pressure. So this is example. So 2NH3 gaseous. Okay. Then platinum at a temperature of 1130 Kelvin gives you N2 gaseous plus 3H2 gaseous. Okay. So what is the rate? The rate is K into 1 ammonia. Okay. 0. So it is independent. So it is 0. So the order is 0. So this is the example. Is it clear? Yes. Okay. So moving forward, next question. What is heteroleptic complex? Give an example. So heteroleptic complex comes from coordination chemistry. Okay, heteroleptic. Okay, Kalki has answered. Coordination complexes that combine more than one type of ligands are known as heteroleptic complexes. Okay, one example is also given. Good, correct. Vedvati, the complex in which metal is bound to more than one kind of donor atoms. Yes, correct. Okay, yes, good. So heteroleptic complexes is what? In heteroleptic complexes, the metal is bound to more than one kind of donor atoms. Okay, so this is a definition. Examples, you can give any one complex. Okay, so CN4Cl2, or you can give cobalt, so NH3, 4, C plus. So any one of the complex can be example of what? It can be example for heteroleptic complex. Okay. Next question. Explain Squart's reaction with an example. Explain Squart's reaction with an example. Okay. Answer. Yes. Explain Squart's reaction with an example. Okay. What is Squart's reaction, students? Okay. Squartz reaction is to get alkyl fluorides from alkyl chlorides or alkyl bromides. Yes. So fluoroalkenes. Okay. So Squartz reaction is what? In Squartz reaction, we can prepare fluoroalkenes. Fluoroalkenes. So fluoroalkenes are prepared by heating the alkyl chlorides. So we can heat the alkyl chlorides or bromides. We can heat the alkyl chlorides or bromides with silver fluoride with silver fluoride. So what can be example? I'll give example of methyl bromide reacting it with silver fluoride. Okay, when you heat this, you get okay plus AgBr. Is it clear? Yes. Is it clear? So this is a Schwarz reaction. Yes. Okay. So it is a Schwarz reaction. So fluoroalkanes can be prepared by heating alkyl chlorides or alkyl bromides with silver fluoride. Okay. Or it is called as metallic fluorides. You can take metallic fluorides. Okay. And you obtained so fluoroalkanes. So this is the example. Okay. Next question. What is Wolff-Kishner reduction? Kishner reduction and write the general equation. What is Wolff-Kishner reduction? Write the general equation. What is Wolff-Kishner reduction? And write the general equation. What is Wolff-Kishner reduction? Yes, what is Wolff-Kishner reduction? Okay, I'll give the answer. The carbonyl group of aldehydes and ketone is reduced to hydrocarbon. Okay, in Wolff-Kishner reduction, what is happening? The carbonyl group. Okay, so you know that carbonyl group is present in aldehydes and the ketones. So what will happen? This carbonyl group in aldehydes and ketones will be reduced to hydrocarbons. So C double bond here is reduced to CH2. Okay, and it reacts with what? It reacts with hydrazine. What is hydrazine? NH2. Okay, hydrazine. NH2, NH2. Okay, hydrazine. So we are making use of hydrazine and it is heated with KOH. What is KOH? Potassium hydroxide. Okay, it is a strong base in ethylene glycol. Okay, so what will be the reaction? So I'll write down the reaction. So carbonyl group. Okay, it reacts with hydrazine NH2, NH2. Okay, and it is converted into. So you get an intermediate imine. Okay, this is further treated with your potassium hydroxide and ethylene glycol. Ethylene glycol. You heat it and you get a hydrocarbon. You get what? A hydrocarbon. Okay, so this is Wolff-Kishner reduction. This is a Wolff-Kishner reduction. So this particular name reaction, it comes in aldehyde, ketones, and carboxylic acid. This comes in aldehyde, ketones, and carboxylic acid. Okay, so what is Wolff-Kishner reduction? So what should be the explanation? The carbonyl group of aldehydes and ketones is reduced to hydrocarbon when it reacts with hydrazine followed by heating with KOH in ethylene glycol. Okay, and you have to write the general reaction. So for the definition, 1 mark, and for the general reaction, you will get 1 mark. Is it clear? Yes. So the last question of 2 marks. Okay, what are non-reducing sugars? Give an example. What are non-reducing sugars? Give an example. So what is non-reducing sugars? So non-reducing sugars are those which do not reduce tolerance reagent. Okay, it does not reduce tolerance reagent and Fehling solution. It does not reduce tolerance reagent and Fehling solution. Okay, so what can be an example for non-reducing agent? Non-reducing sugars. Sucrose. So sucrose is the example for non-reducing sugars. Okay. Yes. Right. Okay. So what are non-reducing sugars? So they do not reduce tolerance reagent and Fehling solution. So what is an example? Sucrose. Understood? So these are the 2 marks question. Okay. So 2 marks question, 6 questions will be given. So out of 6 questions, you have to answer any 3. You have to answer any 3. Okay. You have to answer any 3. Got it? Okay. So next set is part C. Next is part C. So part C also same. You'll be getting 6 questions. So 6 questions you have to answer any 3. So each question will be answered will be for 3 marks. So you have 3 extra options. So whichever out of 6 you can write any 3 questions. Okay. Is it clear? So in the next session, we'll see the 3 marks question followed by the 5 marks question. Okay, so you have part C, okay, and you have part D. So this we'll do it in the next class. I hope today's session is clear. Yes, any doubts? Do you have any doubts? Okay, fine. So the remaining part, okay, 3 marks question, 5 marks question. So these things we'll see in the next class. Okay. So I shall end the session here. Okay. We'll meet in the next class. Thank you.